Take a look at the following names of compounds: methane, butane, octane. Spot the similarity? Well, the obvious similarity is that they all sound similar. They all end with ane. They are also all types of fuels. Methane is used in gas stoves in your science lab or gas heaters in your home. Butane is a lighter fuel that is found in cigarette lighters. And octane is a component of petrol. Let's look at another example: ethanoic acid, methanoic acid, and butanoic acid. These are all types of organic acids. Ethanoic acid is vinegar, and methanoic acid is an acid produced by a type of ant. Butanoic acid is the acid that is produced in sour milk or yogurt. And just like the previous example, they all sound similar. Ethanol is the alcohol we find in wine and other alcoholic beverages, while methanol is a type of alcohol produced during the fermentation of potatoes. There are many types of alcohol, but be warned that only ethanol is safest for human consumption, and even that is debatable. It's not a coincidence that these compounds sound the same and have similar properties. Organic compounds are grouped together in families depending on their properties. These families are called the homologous series. Each member in a homologous series has a group or arrangement of specific atoms that are responsible for the physical and chemical properties of the molecule. We say that compounds with the same special group of atoms are homologues of each other. The special group of atoms is known as the functional group, as they determine the function of the compound. Homologous series is a group of compounds that have the same functional group and can be described by the same general formula, in which one member differs from the next by a single CH2 unit. Functional group: a bond or atom or group of atoms that determine the physical and chemical properties of a group of organic compounds. The homologous series that you will be learning about are alkanes. Alkanes are mainly used as a fuel source. They are recognized by the fact that the whole compound only contains single carbon-carbon bonds and has no other functional group. Alkenes. Alkenes are mostly used as starting material in the production of different polymers, such as common plastics. If there is a carbon-carbon double bond anywhere along the carbon chain, it becomes an alkene. Alkynes. Alkynes are compounds that are commonly used in the pharmaceutical industry. If there's a carbon-carbon triple bond anywhere along the carbon chain, it becomes an alkyne. Alcohols. Alcohols have a wide range of uses, from alcoholic beverages to antifreeze, antiseptics, fuel, preservatives, and solvents. An hydroxyl group, OH group, is the functional group for alcohols. Any compound containing an OH group is an alcohol. Carboxylic acids are all organic acids, such as those found in vinegar, citrus fruits, and certain ants. The functional group for carboxylic acid is carboxyl, that's COOH group. A compound containing this arrangement of atoms is a carboxylic acid. Ketones are widely used as organic solvents, such as acetone, which is nail polish remover. Ketones form on a carbon that is not a terminal carbon, that's a carbon on the end, carries a double-bonded oxygen group, or carbonyl group. Aldehydes also have the carbonyl group. For example, methanol is more commonly known as formaldehyde, and is the aldehyde that is produced on the largest scale. It has many uses, including as a disinfectant and embalming agent. The functional group of the aldehydes are almost like the ketones, except the double bond O is found on the terminal or end carbon. In this case, it is called a formyl group. Esters are fragrant oils that are made from a reaction between carboxylic acids and alcohols. Their functional group is this part where two carbons are joined by an oxygen atom, and one carbon carries a double bond O. One homologous series that is a bit of an exception to the rule is the haloalkanes or alkyl halides. This is when an alkaline carries a halogen. The halogen is still technically not considered a functional group, but the compound is a little fancier than a plain alkane and therefore gets classified as a haloalkane. The same applies to a plain alkene that carries a halogen. The compound is then classified as a haloalkene, even though the functional group is still considered to be the double bond.